Okay, section 2 in chapter 1 looks at the types of data that you can collect and breaks it into some categories depending on what you can do with the data. So it gives you a way of kind of breaking the data down into different parts. So again, I always start off with something at the top that just kind of summarizes the entire section. Statistics analyzes collected data of some characteristics of a population to make an inference or a generalization about that population. Data can be collected from the entire population, that would be a census, or it can be collected from a subset of that population, which we call a sample. The data collected can take a variety of quantitative and qualitative forms, which will limit what you can actually do mathematically with the data. So, first off, qualitative data consists of attributes, labels, and non-numerical entries. Quantitative data consists of numbers that are measurements or counts. Now, I should mention, in the qualitative, it is possible to have a number that is actually a name. And so it's not a measurement or a count, it's literally the name. There was a TV show on in the 60s in which all of the people on the island were communicating with each other by their name, by their number. So it's hey 6, hey 19, and actually part of the storyline was who was number 1, but no one had names. So you have to be careful that just as you see a number does not always mean that it represents a measurement or a count. Okay, then we have our levels of measurement, and there are 4 of them. And we're going to start off with nominal levels of measurement. It's data that can be categorized using names and labels that can't be placed in order, such as gender and nationality. There are no mathematical calculations that can be made at this level. Ordinal level of measurement. Okay, data can now be placed in order or ranked, but do not have meaningful differences between data entries, such as places or grades. So you might say to yourself, oh wait, grades, I can place that in order and they have meaningful differences, but note that somebody could have an A and they have, 97%. Somebody else might have an A and they have 91%. Somebody else has a B and they have 89%. In the one case, the difference was 2%. In the other case, the difference was 8%. So just because you could rank the ABCs does not mean that the differences between those grades was meaningful in a numerical sense. All right, then we have interval level of measurement. Data can be placed in order with meaningful differences, but there is no natural starting point or an inherent zero. An inherent zero is where when you have 0, it actually means none. So, for instance, I have no money. I have $0. That's an inherent 0. Whereas when we say something like, hey, the temperature outside is 0 degrees, that doesn't actually mean that there's no temperature out there or there's no heat out there. It's a relative term that just happens to fall where it does based on that particular temperature scale. So for instance, 0 degrees Celsius is actually 32 degrees below 0 Fahrenheit. 0 degrees Fahrenheit, on the other hand, is not 0 when it's in Celsius. And so those are both relative to their 2 temperature scales. The key is 0 does not necessarily mean none. Same with dates. What is the 0 date, for instance? And then finally, we have the ratio level of measurement. Data such as interval data. However, now the zeros do mean none and can be expressed as a multiple ratio. So, for instance, you can talk about twice the cost or twice the distance. Whereas, for instance, if you said, hey, it's 10 degrees outside versus 5 degrees outside, it's not really twice the heat. It's just, it's a different position in the order of the temperature. Whereas if I said I had $10 versus $5, that would definitely be twice the amount of dollars. So that's pretty much it for the information in Section 2. Most of it deals with looking at the levels of measurement. Let us go ahead and look at a few examples now. So, level of measurement, nominal, ordinal, interval, or ratio. What do you think? Home energy usage this month. Well, that is a ratio. After all, if you had a 0 for your power bill, then that would mean that you didn't use any energy that month. And of course, you can use multiples of some base amount. So this would be a ratio measurement. Okay, Major League Baseball's power rankings. And of course, they do this all the time. You know, who do they think is the best team, the second best team, and third best team? They are ranked. Well, this is an ordinal. You can put them in order, but the difference between first and second may not be the same as the difference between second and third. And in fact, if you've ever looked at the rankings, say the power rankings, they usually have some little triple decimal number off to the side that shows their order, and yet if you were to subtract between any two, they would not necessarily match the difference between any other two on the list. Okay, today's temperature hit a record of 109 degrees Fahrenheit. Well, it's temperature, so it is an interval level of measurement. 0 degrees Fahrenheit does not mean there's no heat. Likewise, 100 degrees Fahrenheit is not twice the heat. It's not twice as hot as it is at 50 degrees. And then, hey, iPad covers come in black and white. Of course, they come in all kinds of colors now, but when they first came out, that's what your choices were, black and white. That would be a nominal level of measurement. These descriptions cannot be placed in a numerical order. You can't really say that, you know, white is first and black is second. I mean, it's really choice, chocolate and vanilla. You can't really say which one comes first. People have preferences, but that's not something that's automatically in order. All right, now, a little bit different way of looking at these same things. Here we have some graphs. And what I want to do is understand what the level of measurement is for the horizontal and vertical axes of the figures. So let's see, in the first one, how many vacations are you planning to take this summer? We have along the vertical axis, percent, 10, 20, 30, 40, 50%. It looks like those who aren't going to take any vacation, they're roughly around 35%. 1 to 2, maybe not quite 45%. 3 to 4 vacations, maybe 12%, and 5 or more, maybe 4%. So, along the horizontal axis, we have the number of vacations, and they're broken into groups. So we have 0, 1 to 2, 3 to 4, 5 or more. Now, before we go over the answer, let's look at the second graph. Here we have motor vehicle fatalities by year, numbered in the thousands. So that means the 32 actually represents 32,000, 33,000, 34,000, and so forth. Note that in this particular graph, with that little squiggly line that's right here, that it is not going all the way down to 0, just to make the graph easier to print out on the page. In 2011, we had almost 32,500. Then it went up to about 33,900 in 2012, and so forth. We see 5 years of fatalities in motor vehicles. So again, in both cases, we want to pick what is the level of measurement for the horizontal. That would be this way. and what is for the vertical, which would be this way. So let's go ahead and look at the answers now. So for graph A, the horizontal axis is ordinal. Now at first blush you might think, well, wait a minute, those numbers 0, 1, 2, 3, 4, 5, those kind of go in order. Why isn't that something else? I mean, ordinal, it's ranked, so yes, they are ranked because 0, that's the smallest one, and then 5 or more, that's the biggest one. However, please note that they do not have meaningful differences. In other words, the groups are not the same size. Okay, 0, well, that's just one value, but then the next group has 1 or 2. The group after that has 3 or 4, and then the last group shown has 5 or more. So that's a really huge group when you get right down to it in terms of numbers, and that's why that's ordinal. They can be ranked, but they do not have meaningful differences between the different groups. On the other hand, the vertical axis is a percentage, and of course percentage is part divided by whole times 100. That is a ratio because in this case 0% would mean none at all. In our second graph, the horizontal axis is now interval. Notice that it's calendar year, and so years and dates and temperatures both go into the interval level of measurement. The vertical is again ratio, because again, if we had 0, that would mean no fatalities that year. So 0 would mean none. And even though we don't have any actual zeros on the graph, the numbers do represent a value. Furthermore, you could, if you wanted to, talk about 36,000 as being a particular multiple of 32,000. In other words, you could really talk about the percent increase in that case, and so that lends it to ratio. So that's it for section 2. Not a lot of different things to go over there, just really looking at the different levels of measurement.